going to start this off a little bit differently than how most presentations have started off. I'm going to introduce myself first and then get into a little bit about the subject. And from there, I'm going to go into the subject. My name is Stephen Hicks. I've been a developer since a very early age. I think I've been developing for about 20 years now, and also self-taught, formally educated, been through C++, Java, some .NET, which is a little bit frightening, but we've been there at times. We're not proud of it.
We're done it. We have done it.
Exactly. I also work for a very large mapping corporation here in Chicago. So, we're all Java developers here, correct? Can I get a solid yes to this?
Yes.
And also a slight groan to what this code is right here. Is there a laser pointer on this? Yes. This code, I'll go back.
It absorbs it.
And so, can I get a guess as to what this code does right here?
Gets and sets values.
For the most part, yes, but
And prints it to string.
Exactly.
Equals.
This is just one single class that represents a data object representing about 5 fields. All we want to know is the first name, the last name, the age, the telephone number, and the address. That's a lot of code just for a single data object. And that's all it does. It just stores those values. It verifies that two objects of the same type are the same. And it also does a comparison. So if you want to sort this in a list, you have that functionality there. That's pretty ugly right there. That's 103 lines. And the next item, the previous class I forgot to mention was a class representing a person. So for more context about how a person is used is that we have an example of a phone book. For a phone book, for the most part, you want to find people by their, let's say their first name, and also, let's say by an address. And as you can see right here, most of the code is exactly the same thing in both functions. But the downside of this is that for every function to write it out properly is that you're going to have to unit test it, and you're going to have to do the process of writing it and duplicating the code, and you have to duplicate code there as well. This class is about 40 lines. That's a lot of code just for simple functionality. So far we have 143 lines of code that we've written. Well, to be honest, it's probably going to be the IDE if you have your IDE configured correctly and that you're very proficient in it. It's probably going to take about a lot more than 20 minutes to write, which is a little bit frustrating for simple functionality in a single class. This, again, represents one data object and 2 simple utility methods. So, what does this talk about? It's that I didn't know that you could do this in Groovy, or that you could do that with Groovy. Again, my name is Stephen Hicks. My website blog is exceptioncatcher.com. This talk does have a GitHub repo behind this with all the code that's been represented on the screen. Of course, the date and the group. So what is Groovy? Has anybody in the room used Groovy before? So we have a few people, definitely not the majority here. That's not surprising. What is Groovy? It's number one, it's JVM based. It's been around for more than 10 years. It's a meta programming oriented language, which means that you can change the functionality of the language at runtime, and you can add methods, you can take away methods, create new classes on the fly, and so forth. Also, most of the syntax is an extension of the Java language, so it's kind of a new language, and it's a half step between a new language on top of Java. Also, 99% of the Java language can be used within a Groovy file. So that means that if you take Java code, you can run it through the Groovy interpreter or compiler, and it will produce almost the exact same Java bytecode that you get otherwise. So, going back to that previous example, let's try to improve this. First, we're going to get rid of all the getters and setters. Why? Because they're not needed. Whenever you have a Groovy object file, it generates the getters and setters for you. In this case, if you mark the fields or properties, yeah, the laser pointer doesn't work on the TV. But if you mark the properties without a final statement, it'll generate a getter and a setter. If you mark it with the final statement, it'll just generate a getter. That allows you to have some mutability there. So firstly, since it generates the getters and setters for us in the bytecode, we can just eliminate them. That means that our class is down to about 62 lines. We've saved 41 lines, and we're down to 60% of the original size. That's a fairly good improvement from the start. But wait, there's more. You remember all the toStrings that you either have to write or generate? Groovy has an annotation for that, and it's called the @toString annotation. This gets rid of a few lines, about 7 lines, as you see up there. And it uses reflection to take in the properties that you have, and it will output those values in the string coming out. On top of that, it has some configuration options that allow you to configure how it's going to be formatted. But for the most part, you don't get a lot of control about how it's formatted because it's not a view and it's not intended to be in that manner. On top of that, let's get rid of some more code. This is the fairly ugly code depending on how your IDE generates this code. It can be quite frustrating to write this code. This is the equals and hash code methods. With this, you basically use the annotation at equals and hash code, and you define what fields are important to you and what should be compared whenever you're making the equals and hash code calls. In this particular case, what is important to me is the first name, the last name, and the address. We don't really want to validate the phone number or the age when comparing two people. With the usage of this annotation, we saved about 19 lines. We're down to 36 lines from 103. So 35% of the original size. We're doing pretty well so far. Another case which can be incredibly frustrating in this example is the compare to method. What this does is that it allows us to sort persons by each other. And in this in the original code, what I had was I had a comparison on the last name, first name, and then the address, because everything of this is going into a phone book. Well, most of it's just boilerplate code anyways. So we have a annotation called sortable, and we can define the order of the properties that are being observed. And as you see in this case, from the equals and hash code and also sortable, the properties used are listed as strings. This is because Groovy is going to go into the particular object. It's going to read the properties. It's going to evaluate those properties values and perform the actions in that way. So right here we saved 8 lines. So we're down to 27% of the original size. So 28 lines in total. The next one doesn't save a lot of lines so far because we didn't use a lot of logging in the first place. I've just generated the original file from mostly IDE-based code. And this allows us to bring in a logger. So this allows us to increase readability here and to get rid of that nasty annotate or the nasty interface that we had before, which it's not the interface, but it's the nasty logger.getLogger and the extension of the class name and so forth. So that takes away a little bit of code, and that makes the code a little bit more readable. It saved about 1 line. It's not that great as far as saving lines, but as far as readability goes, we're doing a lot better. It's a lot more understandable about what we're focused on and doesn't try to add in more stuff than what's necessary. So also it removed an unused import statement because that's coming in through the annotation. And lastly, let's get rid of that constructor. It wasn't really doing anything for us anyways. With Groovy, you can create a new Groovy object with a constructor, and the default constructor with the Groovy object is a map. It defines a map based on the property values right there, as you can see where the Groovy person, last name and first name, and it will use setters to set those particular values. In this case, I removed the finals from the first name and last name, because if those are defined as final, it's still going to try to use that. Lastly, we saved about 6 lines with that, we're down to 27% of the original size, and we have 21 lines from that original 103. And the font, looks like I'm having a little bit of issues with fonts, but as you can see, as the final result, that's our entire class that you saw a few slides earlier. It does the same exact functionality. However, it's a lot more concise, a lot more readable, easier to unit test. For one, why would we need unit tests for getters and setters for the most part? If we don't have unit tests for them, we're going to get complaints due to coverage, but if we don't have them, we won't get complaints for it. So it's going to make you look a lot better if you're using code coverage. So we reduced boilerplate. It took less time to write the code if we were to write this from the start. It means that removing or adding a property is a lot easier. We no longer have to generate new getters or setters, and we don't have to adapt existing compare to methods or the equals and hash code methods. And it allows us to focus on the problem rather than trying to prepare how to solve the problem later down the road. So, you might ask, what kind of magic is going on here? Well, that's all about how Groovy processes the code and the instructions given. With the Groovy compile line, it reads in the source code, parses the source code into a tree and into nodes. As you can see on the left-hand side there is that the assert statement is turned into a block representing the assert statement. It breaks it down into the components there as well. After parsing out the source code from there, it performs the abstract syntax tree transformations, and from there it's the basic pattern matching and replacement based on the instructions given. With these particular annotations that you saw there before, those are provided, but if you wish to extend those, you can write new ones using their DSL, or you can write it through the manual process, which is a little bit more difficult, but you get a lot more bang for your buck out of that. But unfortunately, the AST transformations, that's a topic for an entire day's worth of speaking, and that's covered in the Groovy in Action 2nd edition book. They do a fantastic job with that. Secondly, that other class that we have. For the most part, this class contains 2 unique pieces of code, which those are the conditional statements, where you're checking if the first name is equal to what we're searching for, and secondly, if the current address in the list is what we're searching for as far as addresses go. A lot of this code is duplicated. It's a little bit difficult to be able to go through here and to look for if there's a particular bug in there. Also to note, just a heads up to Todd, we are using optional there in case that if it's not found in the list. I know that you're going to love that. So, things that they're concerning in the original class is that the methods are incredibly generic, but yet they have a little bit unique code, which makes it a little bit difficult to create more tests and to have more and more tests. There's code duplication, and that the phone book is statically bound to the object underneath it. There's nothing in here where the phone book should be responsible for a person's name. But yet, the way that this is written is that you have no choice in this, because you're bounded to the person type and that particular property. So Groovy provides us with some nice alternatives for this. Since we've had closures and we've had what the equivalent in Java 8, which is the stream API, and what do they call it in Java 8? The equivalent to closures? Lambdas, yes. Since lambdas are fairly new, we've had this for about 10 years, which is the closure. It provides a way to write small bits of code, which basically turn into anonymous classes and so forth. But some of the functionality provided in collections means that we can take a collection and we can perform an operation and send in a closure, which is just the unique code provided in this particular case. We're doing a search to see if the item is equal to a particular name. In this case, we're searching through the phone book to look for a person's first name as being named. Groovy provides a lot of different dynamic functionality for if you're using a list and other particular objects. I won't go into that in this particular time. That's, if you're looking more for that kind of details, you look into the GDK. But as I mentioned, is that the phone book really does one thing. It stores objects and it performs small operations in that. So we don't even really need a new class for that. With Groovy, we just take the collection and perform the find operation, and we're good to go. This is similar to the Lambda expressions in Java 8. And the downside about this, which is fairly nice about this, and it's a lot better than the previous example from 40 lines down to 2, is that unfortunately the closure can be a little bit distracting and non-descriptive. You have to process that there's a find operation, that it's in a collection, and that what the particular closure does. In this case, it uses the current instance, which is it. That is a provided name within Groovy, and it does the Boolean operation. So, if you're listening earlier, you heard that I said that Groovy is a dynamic language, and it's focused on meta programming. Some people call it monkey patching. And it can handle missing methods. With Java, you can call missing methods, but you have to trick the compiler to actually compile the code for you and to be able to produce code that will call a method that's actually not there. Or you have to use reflection to do this. With Groovy, it will not go ahead and it will not process everything in an attempt to verify that the methods are there until runtime, in particular cases where it's not compiled in. So it will allow us to have statements such as you can see there where it's underlined, this is IntelliJ by the way, where it says phonebook.findByAge 5. That method doesn't exist. So in this case with the ID says, well, I don't know if that method exists. Groovy doesn't either until runtime. To do this, Groovy provides the functionality in every Groovy object class via some internals, which I'll do some hand waving stuff and say it's just magic. It's called the method missing. This basically intercepts the call before it goes and throws an exception saying that the method is missing. In this particular case, we're doing a check to see if there is the name findBy in the request, and that the arguments, we only have one of those. So from that, we're taking, in the example of phonebook.findByAge, we're going to take away from that string of findByAge, which comes in, we're going to get age, and then from that property name, we're going to have age, and then we're going to do a find on the collection underneath the array list. So we're going to attempt to go through the entire collection using the provided dynamic functions that are provided on the collection, and we're going to send it a closure just to check that particular condition. So in this case, find by age, we're going to attempt to go through the entire collection. For each item, it's going to dynamically check that property age on the internal data object, and it's going to get the value from that and compare it to what you're looking for. If it finds it, it's going to return the value. So two other things that I didn't mention here was that number one, we're using what's called a delegate, which means we're able to access the functionality under that particular method. That means that the particular method that we define here can access the array list underneath it. Secondly, we took the array list and we added a method at runtime. This means that we have an array list, which everybody's used an array list here before, but nobody's ever seen a method called find by age, first name, car type preferred, if you have some kind of car search engine, or any of these methods. So we're adding that particular method to allow Groovy to go to the array list, and whenever the method's called on it, it's going to be able to handle that. In this case, what it ultimately produces is it allows us to define functionality on an array list that contains persons. In this particular case, we're not worried that it's that particular type, but we're going to be able to call on that collection, find by age, first name, last name, phone number, and address, and so forth. Ultimately, this is going to return us all the persons that fit under that criteria that is specified and the property specified there as well. This is a lot more readable than the previous example, which just forced us to use a closure to specify what property we wanted to that value. Lastly, Ruby has this functionality, which this has been around for quite a while. They've been bragging about that and kind of trying to rub it in our faces in the Java community. But we have this in Groovy, and it's awesome. So, special thanks about this talk came from Derek Koenig and Paul King. They are the writers of the book Groovy in Action, second edition. They did a fantastic job in explaining these concepts and to be able to educate other people that may have not had much Groovy experience before. The Grells and Groovy Slack channel, the people who proofread this slide deck, which was Warren Myers, Todd Ginsberg, and Mark Thompson, which two of those guys are here. Also, the Groovy community maintainers and the creator, Gumer LaForge is, I'm not sure about
Dion LaForge.
Yes, I can never pronounce his name. So that was the talk, and are there any questions? So, you first.
Can you really understand how the sortable annotation translated compared to?
Okay. Sortable is another name for the comparator or comparable interface. With the comparable interface, you define you implement that in your code. I'm going to go back all the way to.
So, for two objects to be comparable, how is the order of the fields relevant?
The order is defined by the placement in the array. The first one is the first priority, the second one is the second, and so forth and so on.
Right, so if I had two classes with, say, last name B, first name A, and address Chicago, so how would sortable come in to determine that they're different?
Well, I wonder, are they non-deterministic or
What do you mean by non-deterministic?
so unstable sort?
I think
So if two elements are
This is just more of a comparable thing. So whatever sort that you're using, this is the comparable functionality that's provided.
so. The compare to operations.
Yeah.
So the compare to method would just return the numeric value. So if last name and last name are equivalent, then it would move on to first name, and then if first name and first name are equivalent, and then if they're all equivalent, it'll return 0. And then the stable sort would be
where it implements that consumes
so
the
like
comparable.
we're doing like a tree set or whatever. Yeah.
So it depends on how you. So there's different sorting algorithms, right? So if your sort is stable, then it will be on the same order that it appears on the list that you're trying to sort. If it's unstable, there's no guarantees.
As I mentioned before, in the Java equivalent, that required you to do 3 different comparisons and then to verify if the first 2 are equal, then to go on to the next one and so forth and so on. It's fairly ugly. Your question?
Just as a statement, though it is properly baked into the language itself, but in Java, the project Lombok does pretty much the same stuff.
Lombok does do some of that functionality. It does it a little bit differently. You have a few problems with Lombok, such as serialization, because it generates a completely new class. It's a little bit difficult to deserialize that and keep that consistent. That does provide functionality. That is done through annotation processing in part of after Java attempts to compile, or before Java attempts to compile the code, it does those annotation processing. It works, but also Groovy gives you a lot more. So,
I think the other part probably like if you use string data, it pretty much does the same stuff too.
But that uses your reflections exclusively. So it's a lot slower.
So that was my question too. This is you were covering reflection, but it's not really reflection. Is essentially tree parsing.
Yeah.
So the bytecode it's as fast as you can do it in Java class,
yeah.
right?
Well, before it used to be completely a reflection, but the recent feature within the last 2 years called the compile static came out, and that allows it to compile it down whenever it can get rid of some of the dynamic nature of the code that's requested. So it's a lot faster now, and also using Invoke Dynamic has made lots of speed improvements as well. Does that answer your question?
Got it.
Go ahead.
So there are two forms of AST transformations that are available in Groovy. There's the compile time annotation, which I think a lot of these used to be just runtime.
Yep.
So there was a performance penalty.
So there was reflection.
But yeah, in 2.0, they also provide a lot more support for compile time AST transformation. So in this case, it's effectively generating the same bytecode as if you followed effective Java patterns for most of this stuff.
Well, I'm not a Groovy maintainer or writer,
Yeah.
but I believe that it's a dual approach to that, as you saw on there, that all the properties are defined by a string.
Yeah.
And there's also a properties missing method, so that you can define properties later on down the road.
Yeah.
I would imagine that they did strip that away, but I've never had a case where I've had to.
No,
do that.
you're correct.
Yeah.
So yeah, the missing one is weird.
The method missing, no, so that's definitely that's not AST transformation, that's runtime meta programming. And that would use reflection.
Reflection to
Yeah.
figure it out.
Yeah.
All right.
That's underneath the covers. It's called Expando a meta mapping class, which does the ability to allow you to add in new properties, new methods, and it allows you to redefine the behavior underneath it. There's some nasty problems that you can find yourself getting into, which is called monkey patching again.
That's
for a
right.
reason.
Yeah.
Is that you can redefine methods, the behavior could change later down the road, and you can also run into cases where you set a particular method is not going to be reflected because of threading issues or in static cases. So use carefully is my advice.
So the default is static typing, is that right?
The default it prefers is dynamic typing, but it can still do static typing. So if you have a particular, I didn't put this up here, but if you have a particular type on an object called def, it will attempt to determine what the type is based on what is defined there. Have you used Scala before? Not sure if have you used Python before?
JavaScript.
So it's
JavaScript.
Yeah.
It's just called type inference, right? So like,
Type inference, yeah, that's correct.
Like if you do def foo equals new string, it will assume that foo is a string from that time forward.
From that behavior, how that works is if you have a number such as like 5.23, it attempts to get the least worst particular data type to be able to store that value. So in that 5.2 value, it's not going to store that as a double, it's going to store that as a big decimal. It's trying to play safe there.
But
I'm asking more than this dynamic method. I'm very uncomfortable with that. Is there
That's completely reasonable to say that.
is there some way to
tell it not to do that.
yeah.
You just define the class.
I mean, by convention, you could just like force that you can write like into your linter, don't allow any call to .meta class. But it is like kind of a native feature of Groovy language. To answer your question about the compile static too, like Groovy is actually one of the only languages that's dynamic type by default, but allows you to optionally define static typing at the class level or at the method level. And so you can actually have type checking and all the performance benefits of that on an as-needed basis.
The penalty for using dynamic typing on that same note, there's many people in the Groovy community that disagree with it being there because it encourages you not to define it, and also it has to determine the particular type. If you know what the type is going to be ahead of time, you should always set that particular type.
Yeah.
But also with that typing variance, that does come really helpful whenever you're attempting to bring in mocks, because with Groovy, you no longer have to define a class for every class you're going to use. You could just tell it that this is that particular class, and you don't have to define all the variables. I believe that you had another question? Okay. So any more questions? You guys seem pretty quiet. No questions? You guys loved it? Sounds good.